Welcome to the digital SAT algebra practice lesson. In this lesson, we'll work through questions based on common digital SAT patterns. Okay, we'll practice translating word problems, recognizing equivalent expressions, solving systems of equations, interpreting linear coefficients, and constructing the equation of a line. So I have I'll make videos for each one of the sets, right? For each question, I'll first read the question, the problem. You'll then have time to attempt it independently, right? After the pause, we'll solve the problem step by step and identify the main technique you should remember for similar questions. So let's begin, all right? So in the translating a word problem into equation, this lecture basically, or this video is designed to help you master the art of translating word problems, a vital skill for the digital ACT. Algebra on this exam often focuses on math as a tool for modeling real world situations, right? So by learning to see the underlying structure of a story, you can transform complex sentences into simple equations. All right, so the goal is to build a mathematical model, right? So when you encounter a word problem, your job is to act as a translator. You're moving from English into the language of algebra. In this domain, we're usually looking for a linear relationship, which simply means a relationship that changes at a constant rate. Success on the SAT depends on your ability to identify the parts of an equation with a context, right? So let's first look at, look at the first problem. A delivery service charges a flat processing fee of $12 plus an additional 75 cents or $0.75 per pound for shipping. If the total charge for a shipment was $21, my apologies, which equation represents the weight of the shipment, W in pounds, all right? So there are four options. I'm going to let you read it. And I want you to pause, okay? Try to solve it yourself. When you come back, I will walk you through the way I would solve this. All right, so I hope you were able to solve it properly, and I hope that you got B as the correct answer. Let me tell you why that is, right? So we are looking for three specific math cues, right? The constant or anchor. Look at the value that happens only once. In this problem, it is the $12 flat fee. Whether your package weighs 1 pound or 100 pounds, you pay that $12, right? In the standard linear form, y equals mx plus b. This is your b, or the y-intercept. It is your starting line, right? The rate of change, the jumper, look at the words like per, each, or every. Here we see $0.75 or 75 cents per pound. This tells us that for every 1 unit increase in weight or W, the cost increases by exactly $0.775 or 75 cents. In math terms, right, this is your coefficient or slope, M, right? So the total value, this is the result of the story, right? We're told that the total was $21. This represents the value of the entire expression. All right, to build your equation, think about how the costs accumulate. Okay, multiply the rate of the variable. It is 75 cents or $0.75 for every pound. That is W. That's 0.75 W, right? Fixed cost. So you'll add that flat fee that doesn't change plus 12, right? So the result together, these must equal to the total given, right? So 0.75 W plus 12 equals 21. So this message matches your choice B. I hope that you understood that. So truly master this. Don't just look at the equation, okay? Imagine Imagine the other languages this story speaks, the tabular language, right? It was made, if we made a table, 0 points would cost $12. £1 cost would be $12.75. 2 pounds cost will be $13.50. Notice the jump is always like 0.75, right? The graphical language, if you're drawing a graph, the line would cross the vertical axis at 12, your flat fee, and rise with a steepness of 0.75. Now, this is key, right? Verification, the bedrock of equivalence, right? The first step is to remember the principle of equivalence that we talked about in previous lecture. An equation is a statement that two expressions have the exact same value. You can verify your choice by testing the logic. If the weight W were 10 pounds, the choice B would be, 0.75 times 10 plus 12. So the equal would be $19.50. If choice A were correct, that is 12W plus 75, the pounds would cost, the 10 pounds would cost us, a staggering $120 plus 75. So by checking the structure of expressions, you can easily catch errors where the constant and the rate have been swapped. So to wrap it up, when translating SAT word problems, always ask, what is my starting amount? That is your constant, right? B. What is my jump for every unit? That is your rate coefficient M, right? What is the final result? This is what the equation equals. By identifying these pieces, you aren't solving a math problem. You're building a model of the real world. I'll see you in the next practice test.